Alright, so this section is on graphing quadratic equations, and there's kind of two basic things we want to do. Number one is learn how to graph them, and number two, learn how to find those points that you see listed up there. So what is the vertex of a graph? What's something called the axis of symmetry? How do we tell if it's going to open up or down? How do we find the max and the min? And then how do we find something called the domain and the range? Okay, so first of all, what is a quadratic equation? It's something that looks like this. It's something where x is being raised somewhere in the equation to the second power. And then that is called the quadratic term. This one is called the linear term, x is raised to the first. And that's the constant, that's just a number. A, B, and C stand for numbers. Okay, what you see there, ax squared plus bx plus c, that is called writing something in standard form, which means that the x squared comes first with a number in front of it. A stands for a number, so do B and C. And when you graph equations like this, you get something called a parabola. It's like a U-shaped graph. So if we graph these correctly, we know we should get something that looks like a U. Alright, so the first thing we should do whenever we're graphing is we should find the vertex of the graph. And the vertex of the graph, if this is our U-shaped graph, the vertex is like the bottom point. That right there, that would be the vertex. If it was pointing the other way, the vertex would be the top point. So how do you find the vertex? The vertex always occurs at this point. The x-coordinate of the vertex always occurs at negative b over 2a. So what does that mean? What is negative b and what is 2a? Well, remember that quadratic form or standard form of a quadratic equation is written like this. It's written as ax squared plus bx plus c. So if we look at this equation, the number in front of x, that is a. So a in this one would be 3. Sorry, the number in front of x squared. The number in front of x is b, so that would be negative 12. And the constant term, that's this one, c, would be equal to 6. So if we want to find the vertex, we take negative b, so negative 12, which is positive 12, over 2 times a. And a in this case is 3. So over 2 times 3, which is 6. 12 divided by 6 is 2. This that we just found, that is the x-coordinate at the vertex. So the next thing we need to do is make what is called a table of values. And to get a good parabola, you really only need 3 points. Our equation that we're using is this right here. And we just found the point that goes in the middle. We just found the vertex, which is 2. And then we need a point on either side. So less than 2 would be 1, more than 2 would be 3. How do you find the y? You just plug in 2 wherever you see an x. So if you notice that top equation has x's in it, now I'm plugging in 2's and solving. And when I solve each of these, 3 times 2 squared would be 3 times 4, which is 12. Minus 12 times 2, that would be minus 24, plus 6. 12 minus 24 is negative 12, plus 6 is negative 6. So our point on the graph, would be 2 comma negative 6, which is right here. That's the vertex. How do you tell if the graph should open up or down? You tell based on this number right here. If that number is positive, which it is, in this example it's going to open up. And if that number a in front of the x squared, if that is negative, it's going to open down. Okay, then same thing for these other ones, so let's plug in 1 right here. And here's another nice thing about the parabola. Parabolas are symmetric. So that means the 1 and the 3, when I plug them in, are actually going to give me the exact same number. That's supposed to be a 3 right there. So this is going to be 3 times 1 squared, which is 3. Minus 12 times 1 is minus 12, plus 6. Negative 3 minus 12 is negative 9, plus 6 is negative 3. This one down here, just to prove that it's the same, 3 times 3 squared. 3 squared is 9, times 3 is 27. Minus 12 times 3, that would be minus 36, and then plus 6. 27 minus 36 is negative 9. Negative 9 plus 6 is negative 3. So notice that these are actually the same. So we have points at 1, negative 3, and at 3, negative 3. Here's 1, negative 3, here's 3, negative 3, and then you just connect the dots and you get your parabola that is opening up like we said it should. Okay. So that is how you graph. We found the vertex, and then we also want to be aware of 2 other things. Number 1 is this vertical line that I'm drawing right here. That is called the axis of symmetry. It's called the axis of symmetry because it's a line, it's an axis that symmetrically cuts the graph in half. Right? If you were to take this parabola and fold it along that line, it would be a perfect copy of itself on either side. So what is the axis of symmetry? It's x equals this number. Remember the vertex that we found in that table was 2 comma negative 6. this number is the axis of symmetry. X equals 2, that's the equation of that purple vertical line. Negative 6, on the other hand, is the minimum value. It's the smallest point on that graph. That's y equals negative 6. Okay, if it were a parabola that was facing the other way, if that were the top of a parabola, then that would be the maximum value. And the last thing is the domain and the range. The domain is what x could be. So if you look at this graph, x is going, well, this line right here, this is actually going forever to the right, and this line keeps drifting forever to the left. So since x can go forever in either direction, we would say x could be all real numbers. That's what the domain refers to. Domain refers to what could x be. The range is not all real numbers, because even though these arrows right here keep going up forever, they don't go down forever. They stop at that y value right there. What is that y value? It's negative 6. Y can be anything at negative 6 or above. So the way that you would say that is y is greater than or equal to negative 6, and that's the range. So for every parabola, the domain is always going to be all reals. The range is always going to either top out or bottom out at that minimum or maximum value. Alright, and that's just a picture of what we talked about with the vertex and the axis of symmetry going through it. Alright, let's try to do, let's see here, let's do maybe one more. Let's try to find a good one here. Let's do this one right here. Determine, so we'll do this whole thing. We'll graph it, we'll find the max and the min. Actually, we'll go back a page. This one's a little bit better. Let's do number 2 right here. We'll graph this, find the max and the min, all that stuff they want right there. Vertex, axis of symmetry, min, max, and y-intercept. So let's start with the vertex. The vertex is, let's write our A, B, and C. Our A is this number, so 2. B is negative 4. C is negative 1. Okay, so the vertex, V, is going to be negative B over 2A. Negative B will be negative negative 4 over 2 times A. A is 2, so 2 times 2. Negative negative 4 is 4, and 2 times 2 is 4. So there is the coordinate at the vertex. So we'll put that in the middle of our table. And y is this equation right here. So to find the rest, we'll put a number below 0 and a number above, a number below 1 and a number above 1. And then let's plug each of these in. If you plug in 0 for x right here, you get negative 1. So 0, negative 1 is a point on this graph. If you plug in 1, we have 2 times 1 squared, which is 2. Minus 4 times 1 is 4, so 2 minus 4 is negative 2. Negative 2 minus 1 is negative 3. So we have the point 1, negative 3. That's the vertex right there. 1, negative 3. And then we know from before that because this is symmetrical, this number, and you can check it when you plug in 2, you'll also get negative 1 if you plug in 2 for x right here. So there's our parabola. We knew it was going to open up because this a value is positive. Okay, now here, let's find the other things. We found the vertex. Vertex is 1, negative 3. The axis of symmetry is this green line that's going right through the vertex. It's symmetrically cutting it in half. What's the equation of that line? X equals this number. X equals 1 would be the axis of symmetry. Does this have a min or a max? Well, it actually has a minimum. You can see that's the lowest point on the graph. If the parabola looked like that, that would be the max value. It opens down, but this is a min. What is the min? The minimum is y equals to negative 3. That's this number right here. And then finally, the y-intercept occurs when x equals 0. So we found that when we plugged in x equals 0, we got this number, negative 1. So anytime you want to find the y-intercept, just plug in 0 for the x's, and it's going to be that number right there. Okay, so that's a summary of 4.1, the domain. Just to recall that too, the domain is always all real numbers. The range right here, the range for this one is going to be anything where y is bigger than that yellow dot, because it's going up, so y is greater than or equal to negative 3. And that is a brief summary of 4.1. That's how to graph parabolas or how to graph quadratic equations. In the next section, 4.2, we'll talk about how to use that in real-world problems like this one right here.